A very good afternoon and hello guys. How are you guys doing? Some ठीक हो आराम से हो? What you see on the screen right now is the northwest Pacific forest in the west of America. Here in the year 1990, a nationwide controversy took place. Here's some of the photos of the controversy. Here you see an old growth forest right at the shore of Oregon State. And so the controversy was so huge, the President of America back then had to come to Oregon with his cabinet. I'll show you the video in a while, but let me tell you why and what led to the controversy. The controversy revolved around this little bird named northern spotted owl. The spotted owl was considered an endangered species in 1990 by the US Department of State, and so they considered logging illegal, basically cutting of trees illegal in the Oregon State. Luckily in Pakistan we don't give much attention to owls or birds, but see in America they feel very strongly about their wildlife. And so you just saw the president and the vice president back then, George Bush, he with his cabinet flew from Washington to Oregon to put a ban on the timber industry. And so the timber industry faced a huge loss. It was ordered that there would be no more logging of old growth forest. Timber industry loses around 30,000 to 1 lakh jobs. And the timber mafia protested, which was sort of called the Owl War. It went throughout the Oregon State. Timber mafia then cited some research. Obviously, if you are playing in money, you do all things in your self-defense. So they in their self-defense, cited some research stating that the logging or the forest has nothing to do with the owls' decline, owls' population decline. In all these, this hustle and bustle, there was a group of mathematicians and a study led by R.H. Lamberson from the Department of Mathematics at Humboldt State University. So it is a field in mathematical ecology where they started looking at the population of the owl, the spotted owl. And so that study, as we now know, is a case study of population dynamics. I'll tell you a bit about population dynamics and then we will move on to towards our main topic and subject. So you will have to bear with me. There will be chocolates at the end of the presentation, and maybe this will be a little long, but you will have to bear with me again, I'm sorry. As a life cycle of a spotted owl, the first step of population dynamics is modeling the populations in different stages. And so a spotted owl generally has 3 stages in its life cycle. A juvenile stage where the owl is up to 1 year old, the sub-adult stage where it is 1 to 2 year old, and older than 2 years, which is basically considered an adult. So you have 3 different stages. And then you have a population dynamics stage 1, step 1. What you do is model the population in early intervals. This is often denoted by K. So we have a variable K, and then you take different values. So for year 1, it's for the first year maybe 0 and 1, 2 and 3 and so on.
Okay, just thank you so much. What's up, clapping for Saud. Start was really cold and thought-provoking. I really mesmerized by the idea you took us to this point, so I appreciate.
Thank you,
and,
sir.
Once again, special appreciation once you will deliver us chocolate. Okay, clapping. Okay. Good luck.
Thank you, sir. Okay, so the step 2 is the population at A or K can now then be described by a vector. So you basically define it as a vector. where here we have xk as a vector, and then you have jk, sk, and ak represent the juvenile, subadult, and adult. And k is basically, as we said, it is the population at yearly intervals. So you get this vector, and then from this vector you move on to step 3 and using actual field data. This is from the actual field data, but generally what you do is like Lamberson and his group did, you create a stage matrix model. The stage matrix model, the one like here, defines the data. And it tells you what the population of the specific animal or the specific study that you are conducting will be in a few years. And so I have a little something that I wrote here. Yeah, and so what you see is the 0.33 is the number of adult ovals in a year k based on the average birth rate. And so 18% of the juveniles survive to become adults and subadults, and 71 and 94% of the subadults survive to be counted as adults. This is the way their population, their life cycle moves on. So you have 33% moving on to subadult and adult, and subadults and adults moving on to adults, and then they live.
My question, or maybe you will explain in this stage, because the X sub K, J sub K, these are the different phases of the oval, okay, in the life cycles. So K plus 1 represents what? That increases somehow what?
Sorry, sir, I'm very sorry, I forgot to tell you about this.
Yeah,
Exactly.
this is the thing. Let me first. JS, okay, A, these are the 3 phases, okay, but okay, I will
The K,
explain. Yes.
like we said, the K is the yearly population at yearly intervals, and then so the K plus 1 is the population next year.
Next year, wow.
And so through this study, the stage matrix model here,
You need to explain this very clearly, because we are eager to listen to you, inshallah.
okay sir. So the stage matrix model is a difference equation of the form x into k, xk plus 1, which equals to ax of k. And such an equation is called a dynamical system or the discrete dynamical system because it describes change in a system over time. This is an application of eigenvalues or eigenvectors.
Okay, could you please help? Because we want to ask tons of questions. Am I right, my students? Yeah. Okay. First, if you allow me, or you want to ask?
Then we will allow you.
Okay. This x sub k.
Yes,
X
sir.
sub k is representing what? The variable x, 3 phases, 3 cycles.
So xk is the
You told us about-
population
Yeah,
of all.
there is no population, it's 0. There is some, you can say, childhood or some adulthood or some, these are the phases, okay?
Yes, sir.
Am I right?
Yes, sir.
Okay, good. And K is the index representing 4 possible values, 0, 1, 2, 3, 4, okay? So, what is the matrix A then? In matrix A encompassed what? What kind of parameters or what kind of things? In the elements of matrix A represent what?
Sorry, sir.
Okay, my children, we are here for learning. The matrix A is encompassing different elements, okay?
Yes,
like
sir.
A11, A12, A13,
Yes, sir.
A21, okay? What are these elements? Actually, we are curious to know about it.
Yes, sir.
Yes. Somewhere there are, yes.
That's about. Hold on a second, sir.
Okay, I'm so sorry.
I guess your question is regarding the A here.
Yeah, this is a very interesting. Okay.
So we'll come to this part. We'll come to this part just in a while.
Yes.
Okay, sir. And so through this study, they concluded that it was not basically, it was actually the logging, which the timber mafia said was not, and they cited research to prove themselves कि जी हम अगर दरख्त काट रहे तो it is not affecting the population of the owls. Whereas with their study, they proved that the 60% survived to leave the nest, 60% of the juvenile population, they survive to leave the rest nest, but only 30% can find a nest. And for an owl to survive, they must find a nest which consists of around 100 hectares and around 4 miles. So for each owl, there must not be any other owl in its surrounding 4 miles. And if there is any owl in their surrounding 4 miles, then they die. And so this was the reason, that significant reason for that is the clear cutting with the logging took place and the forest was cleared. And so whenever they would leave the forest area, they would be attacked by other owls. There are different types of owls, and I'm not going to that. And so they would be attacked by that, and the 50%, so the population would decline. But if the 50% population that left their nest survived and they found a nest, the population would have thrived. The population would have increased, which was their study.
Okay, so in this situation, your matrix A tells us about. Can you please go to the matrix A?
Yes, sir.
Because here we are for learning. Okay, no, the matrix, yes, elements. So first 0.33 is telling what? Please.
The first, so I told you the J represents here juvenile stage of the spotted owl. And so 0.33 of the juvenile population, they survive to become sub-adults and adults.
Okay.
And then the 18% survive to become sub-adults and adults, and 71 and 94% of the sub-adults and adults then live alive and then survive.
If you don't mind, I am really sorry, it's difficult for me to write. So this one here, please, I need your kind attention. My child is speaking out very well. This zero, this is the weight parameter. Weight parameter will multiply. Okay, first row will multiply with the column. Okay, kind of vector. So first this 0 will multiply with j sub k. It means the weight value, or you can say that the childhood of many owls are almost negligible, or you can say that become diminished, or you can say will not exist. Okay, once there will no nest, proper nest, then you can say owl will not lay down the eggs, or so no eggs, then the childhood very you can say existing of the fresh you can say newly born owls almost impossible.
Yes, sir.
0 representing this. Once 0 will multiply with this, then whole term will become 0. Similarly, this 0 is even the like you people, okay, young generation, almost, okay, they are not clever enough to survive. Are you getting my point? So they are also become 0. Only this 0.33 almost kind of a passing criteria, just like me, old people can survive somewhere, even without the sufficient amount of the trees, they survive somewhere, they can hide. So this 0.33 multiply with this one, then this is talking about the amount of or number of the adulthood. Are you getting my point?
Yes,
so this is the thing. Clapping for Saud.
The population dynamics will come back to that in after we are done with the study. There's an example on population dynamics at the end. So population dynamics, this was an example of eigenvectors, and I wanted you to go through a case study which is in one of these books. You have used to go through a case study based on the American model of education. You study a case and then you come to the main topic. And so this is what I wanted to do. We studied population dynamics, and then we will move on to eigen values and eigenvectors. But before we start, I want to show you a little clip. So if you would closely look at what's happening here, and we'll get back to it after. We'll get back to our reflection after the video.
Tacoma Bridge, Washington, opened only a few months ago, was built at a cost of over $6 million. But misfortune overtakes the great structure. These are some of the most amazing pictures ever recorded by a newsreel. The actual collapse of the world's third largest suspension bridge. Only a 35-mile-an-hour wind is blowing, but this apparently sets up a rhythmic swinging of the bridge, which increases with each swing. Finally, the swinging road and the suspension cables give way and plunge into the water below. Fortunately, the only casualties were a car stalled on the bridge and a dog.
You don't need to clap at that point, sir.
Before you are speaking, I would say I should quit the teaching because such an interesting way of teaching is.
Yes, sir.
You are my no, sir, you are our inspiration, and we want you to teach Okay, sir, so this the reason for the fall of the bridge. Do any one of you know what was the reason for the bridge which costed the United States of America $380 million and was the third largest suspension bridge ever in the world? What led to its collapse? Any idea?
The dog.
Resonance frequency.
Exactly, resonance. Thank you, sir. Then you And so one small equation can lead to loss of $380 million, or maybe if it was luckily that there were no people. If there were people, then it would lead to the death of so many people and so much money and so much wealth. All this took place because of a small mathematical error that the engineers did. And so one of the applications of eigenvalues or eigenvectors is it is used to provide very critical data for designing of bridges. And so the natural frequency of a bridge is the eigenvalue of the smallest magnitude of a system that models the bridge. The engineers exploit this knowledge to ensure the stability of these constructions. Here we have a very interesting point, the natural frequency of the bridge. And so if the resonance, reaches the natural frequency, then the bridge collapses. And that was the reason for the collapse of the bridge. Now we'll come to our topic. And this, before all this, it was just a trailer, and now we'll be discussing.
I really appreciate that Saud took such a long time, and from my side this is present for him because no, this is okay. I can take it. Clapping. Well done, very well. Yes, please.
So now we'll discuss eigenvectors and eigenvalues, which is a very important concept in linear algebra. And so you'll find a lot of resources, and I'll tell you where the resources lie. But before, let's discuss what is eigen. So the word eigen is a German word which means characteristic.
I will ask you many questions from this topic in exam, though we will study a little bit more about it, but please pay attention, okay, please.
The word eigen or whatever you pronounce it, it's a German word, and the meaning of this is characteristic, proper, or special. And so when we say eigenvalues, we mean characteristic value or characteristic vector, or special value or special vector. Why it is special, we will come back to that. And so it was first called eigen by a German mathematician, David Hilbert.
Okay, before proceeding further, I would like to say that what is the concept of eigen? Eigen is the kind of a characteristic, similarly like a characteristic of human. If someone is speaking truth, so we can say truthful person. Okay, now weight value. So in the bridge collapsing, weight value, how much he is truthful, too much or maybe some, you can say oftenly, or you can say sometimes seldom, he can speak out some truth. Or similarly, if we are talking that he is a liar, how much? Okay, so this is the frequency. Are you getting my point? And this is if the characteristic of a person, if it is small or if the value is larger one, so its weight, okay, the weight of a vector changing the situation abruptly, or you can say amicably, Saud will further it.
Yes, I'll give you a human analogy from this. If you consider all the human beings in the earth, irrespective of their religion, someone is a Christian, someone is a Muslim, and if you have a person that is neither of that, what is it that the person do or has which makes him a Muslim? That very characteristic or special or eigen quality that there could be 1,000 answers, and so goes for eigen. You have a lot of special values and special characters that leads to that very answer.
Because only if we say that I just recite the kalma or for entering in some particular religion. So many Chinese or Korean, once they are working in our religious place in Makkah, they are reciting the kalma, but it does not mean, okay, so we should follow or we should abide by the rules set by our Holy Prophet Muhammad sallallahu alaihi wasallam as Allah wants. So there are certain things, and these are the eigens, okay, values. Please.
Okay, so coming back to our topic, what are the prerequisites for this course? Before you study any topic, any subject in whatever study that you do, it is always a good thing to consider the prerequisite and so forth. For this specific subject, you must know the rank of a matrix, how to find the rank of a matrix. You must know matrix dependence and independence, which luckily one of my partner Kamar explained. And then you must also know how to find the determinants. And then, so these were the prerequisites, and now we will discuss what are some qualities that the vectors must have for it to have an eigenvalue or a vector. So it must be a n by n square matrix, and whatever we will study in this course of subject, it will be a square matrix. And it must be non-trivial. Non-trivial means the determinant of coefficient will not be equal to 0. So these are very important points when you are solving the problem in exam. This is something maybe you will try to remember. And so it must be invertible, which means the determinant must be 0.
Determinant must not be 0.
Must not be 0. Sorry.
Okay, that's okay. I'm so sorry. It's a part of slip of tongue. That's okay.
Yes, sir. And so Gilbert Strang, who is a professor. Gilbert Strang, who is a professor at MIT, Massachusetts Institute of Technology, which is the leading institute in technology in the world. According to him, and in this book, which is in the library, where you may find it there. Here I'll tell you the page number. Sorry, it is taking me a while. Page number 234, you will find what he wrote about the eigenvalues and eigenvectors. And this is what he says. He says whatever we have studied before this subject was the first half of linear algebra. And this is a formal introduction into the second half of linear algebra, which I think is very important. Okay, we are moving into a second phase of linear algebra. And so far we have discussed linear transformations in the form of x is equal to b. The new problem is x into some way, x is equal to some scalar into x. And so this problem is solved by simplifying a matrix, making it diagonal if possible. We will no more use elimination method, because elimination messes with eigenvalues and we do not want that. It changes the eigenvalues.
Yeah, this is a beautiful concept, and I appreciate to Saud that he is leading us into the second phase of linear algebra. And here, the AX, can you write please let's say AX equal to lambda X?
So,
Okay,
here.
Oh, okay, thank you so much. Okay, so this I think Saud will also explain, but I really apologize. Okay, he can drink little water, so I can speak out my mind.
Yes.
So this lambda is representing some kind of a weight value, or you can say eigenvalue. And this, if the value is small, then of course effect will small.
yes, sir.
This is the same thing that Saud is looking very smart today. If he could not, okay, his dressing can be a casual, but he gets ready for this presentation, so look very smart. So eigenvalue, okay,
Thank you,
dressing
sir.
is improved. So weight of the dressing is improved technically. Okay, clapping for him. You can say that eigenvalue is similar like the weight, okay, the
Yes, sir.
importance of dressing kind of thing. Good.
Okay, so considering we have a n by n square matrix, then this equation, this is very important, where A is some matrix which is of the form of the order n by n, and this is a scalar quantity, or like sir said, scalar quantity or weight for eigen. Then the scalar value lambda is the eigenvalue given above. The equation is non-trivial, and so non-trivial means it must not be zero. And x
Remember this, I will ask this thing in exam, okay, MCQs maybe.
and x is equal to lambda into x, a non-zero vector in the space natural number is an eigenvector. So this is basically the formal definition, and then we will move on to the definition of the eigenvectors. And I'll distribute among you some notes that I got with myself. Yeah.
Okay, please help.
Please share the notes, as I didn't know कि इतने ज़्यादा लोग होंगे तो.
I think this is somehow challenging for software engineering students. Anyhow, let's see. Someday you can conduct this kind of session. Yeah, let's see. Okay, please.
And so we just wrote x is equal to a lambda. This is a lambda of x. Then for it to be, we'll move this lambda x to this side, which will become an x. And taking x as common,
Yes. I can go.
we get this value. And so you know here now that this is a scalar quantity. And you cannot subtract a scalar from a vector. So what must you do to subtract it from a scalar? You multiply it by an identity vector. And so anything multiplied by the identity vector is that thing in itself.
Then become it's a matrix.
As a matrix of that specific.
Clapping for sound. And he will.
And so we get this value. Like I discussed, we'll get an here, can we write this specific term as B, and then it will become Bx is equal to 0. Anybody has an idea what this is? Bx is equal to 0. This is a homogeneous linear system.
So who will explain this homogeneous linear system? Anyone know?
Maybe Suleiman,
Oh,
maybe Danish.
what's the theme on this?
Huh?
Okay, we will discuss it later. It's my job. I'm sorry.
And so I told you for eigenvalue of this to exist, it must have this homogeneous linear system must have a non-trivial solution, and for Bx to have a non-trivial solution.
Okay, so for student curiosity, I just want to say in simple words.
Yes, sir.
Once this B, okay, some kind of a also a kind of a weight parameter by following the eigenvalues and element of A. So once this weight parameter multiply with variables and there is no change, no outcomes, then we say the system is homogeneous. Okay, I'll explain later, but this is for the moment we should not worry.
And so this is for it to be non-trivial, it must have a rank which is rank of B must be less than n.
Okay, see if there is a matrix A belong to some n into n. N is what size? Okay, for example, 2 by 2. If we say the matrix of size 2 by 2, or you can say 2 by 2 size of matrix, then your matrix B which you got from A minus lambda I is identity. If you multiply with lambda, then it again lambda. Okay, so this B should be what? This B basically rank. You know how my brilliant students Zainab and their groups explain the rank of a matrix. So should be less than this, for example, n into n, that 2 by 2 should be less than n, less than 2, or maybe a rank of 1. Okay, are you getting my point? Yes, sir. You want to explain this concept. Thank you for...
Okay, whoever gets correct one for this, the first answer.